In 1938, a man named John Bradfield proposed an incredible idea for Australia: to revive the continent's arid heart with a massive artificial lake. Known as the contemporary Bradfield Scheme, the proposal was one of the most ambitious ideas of its time. But why a massive artificial lake? John Bradfield, born in 1867 in Queensland, was a genius engineer. He was known as the father of one of Australia's most iconic structures, the Sydney Harbour Bridge. Designed in the 1920s, this bridge was the longest arch bridge in the world at the time, and it became an engineering marvel that transformed Sydney. Bradfield didn't just build bridges, he was also the mastermind behind Brisbane's Story Bridge. Throughout his career, he worked on railways, water systems, and urban planning. Educated at the University of Queensland, he rose through the ranks of the New South Wales government. He earned the first engineering doctorate from the University of Sydney and became known as the father of modern Sydney. Bradfield knew Australia's geographical challenges very well. While the continent's coastal strips were fertile, the interior was as dry as a desert. He spent years thinking about how to correct this imbalance. In the 1930s, nearing his retirement, he unveiled his greatest dream: to redirect the rivers in northern Australia, fed by monsoon rains, into the interior, creating green valleys in the heart of the continent. And everyone began asking the same question: is this really possible? Bradfield's idea was this: to capture the Tully, Herbert, and Burdekin rivers, which rise on Queensland's coast and flow eastward, using dams, and divert them west of the Great Dividing Range. From there, the water would be channeled into the Thomson River, eventually flowing southwest to fill the usually dry Lake Eyre basin. The resulting body of water would be a massive inland reservoir, often called an inland sea for Australia. This would allow irrigation of the country's waterless central regions, creating thousands of square kilometers of new farmland. The project's proposed map showed exactly this route. Monsoon river waters pumped through pipes, tunnels, and dams to fill Lake Eyre. Think about Australia, the driest inhabited continent on Earth. 70% of its land area is desert or semi-desert. While coastal cities like Sydney and Melbourne hold most of the population, the interior is empty and unproductive. Bradfield saw this imbalance. In the 1930s, Australia was in the grip of the Great Depression. Drought was devastating farmers and the livestock industry. The benefits emphasized by the plan's supporters were impressive. Irrigated farmland. The project could create more than 7,800 square kilometers of new farmland in inland Queensland. That's roughly equal to 9 million football fields, enough to imagine vast production zones in the continent's center. With irrigation, the interior could produce cotton, sugarcane, grain, and orchards. This would boost food production and strengthen exports. Even today, Australia is a strong player in agricultural exports. Back then, the plan could have turned it into a global agricultural superpower. Soil erosion could be controlled, and the advance of desertification slowed. Hydroelectric power. The large dams were projected to generate around 370 megawatts of electricity annually, comparable to the capacity of a small nuclear plant. This meant that the rivers of the north could also help meet the country's energy needs. Climate improvement claims. Some officials argued that a large inland body of water could moderate the region's climate. For example, a full Lake Eyre replacing dry ground with a heat-absorbing water surface might lower regional air temperatures and even alter rainfall patterns. Other potential benefits. The scheme could open new opportunities for tourism, recreation, or biological production, such as algae farming, and support the development of arid regions. Diverting some of Queensland's floodwaters inland could also help reduce flood risk on the coast. As you can see, Bradfield's proposal promised a very different future for the continent. At the time, the nation was still young, recently independent from the British Empire, and searching for its identity. This plan could have been a source of national pride, especially in the gloomy atmosphere of the late 1930s. Large infrastructure projects like this seemed attractive. With Bradfield's vision, Australia would gain abundant water and fertility, improve its climate, and open vast lands to agriculture. But every dream faces obstacles. Bradfield presented his plan to the Queensland government in 1938. At first, it stirred excitement. Newspapers ran headlines like, greening the desert. Politicians were intrigued by the promise of national development. Bradfield, with the success of the Sydney Harbour Bridge behind him, was a trusted name. People listened. But when World War II broke out, everything changed. In 1939, the war began, and Australia redirected its resources toward defense. Dams gave way to tanks, tunnels to trenches. Even after the war, as the economy recovered, the cost of the project was daunting. Bradfield's own calculations ran into billions of pounds, a staggering sum for that era. The reaction of the time was mixed. Some scientists and engineers supported it. Queensland farmers were hopeful, but critics multiplied. Geologists argued that there simply wasn't enough water. While northern rivers received heavy rainfall, half the water could evaporate before reaching the interior. Hydrologists warned of salinity problems. The transferred water could salt the soil and ruin crops. Geography posed another obstacle. The Great Dividing Range stood like a 1,000-meter-high wall. Drilling tunnels and pumping water over it was technically possible, but expensive and risky. Professor G.W. Leeper of the University of Melbourne claimed that Bradfield's plan lacked scientific basis and wasn't supported by adequate data. Measurements from the 1930s were insufficient, and barometric elevation estimates could produce misleading results. As time passed, the project's practical issues became clearer. In 1947, a technical review led by W.H.R. Nimmo showed that Bradfield had overestimated river flows and available water. The usable water figures were far too optimistic. Nimmo's report also noted that costs and technical challenges would make the project difficult to execute. This critical assessment triggered the plan's first major setback. Moreover, the enormous scale of the project stretched the technological and financial limits of the time. It would have required hundreds of kilometers of pipelines, thousands of pumping stations, and massive dams. Construction technology was not yet suited to such extensive pipe and pump systems. Ultimately, Bradfield died in 1943, just 5 years after first presenting his plan. But the idea didn't die with him. It was discussed again in the 1950s and 60s, and with minor modifications, resurfaced several times. In 1981, the opposition party in Queensland proposed a new Bradfield version. In 2007, Queensland Premier Peter Beattie even called on the Bush administration to conduct a new review, but the preference at the time shifted toward other solutions, such as desalination instead of huge dams. In 2019, some federal political leaders requested a re-evaluation of the project. That same year, Queensland's opposition party defended it as a long-term strategic investment. Today's scientists and governments don't look at this old project through nostalgic glasses, but modern assessments find the Bradfield scheme unsustainable. A Queensland government report published in December 2022 completely scrapped the idea. It emphasized that despite the enormous infrastructure costs, the available water supply would still be insufficient. Estimated costs exceeded $30 billion, and the report's conclusion was blunt. If there is consistently insufficient water, no Bradfield plan can work. This confirmed scientifically that the project was simply unfeasible. Similarly, recent studies by CSIRO, Australia's National Science Agency for Mining and Water Research, have debunked the idea. According to CSIRO's 2020 analysis, while it is technically possible to transport water over such distances, building the infrastructure would be economically unviable. The research also found that the maximum amount of water that could be taken from the north was much less than Bradfield's estimates, about half. The conclusion was that using water close to where it falls is much more effective for regional development. In other words, data from the 2020s recommend building small-scale mini-water grids near the coast instead of massive inland projects. In summary, scientific and economic analyses today consider Bradfield's grand plan impossible. His legacy, however, has inspired smaller-scale, local, and scientifically supported projects. These include aquifer regeneration, seasonal ponds, water management in coastal plains, renewable energy-powered pumping pilots, and wetland restoration, approaches that aim for many of the benefits of the big lake idea with less risk and more manageable costs. This is a pragmatic shift, many small steps instead of one giant leap. Still, it should be remembered that Australia's interior remains at risk of drought. Even though Bradfield's original vision was never realized, the debate is not over. As new data emerges on water resources and agricultural climate, similar questions could resurface. For example, if climate change, moisture distribution, and technology see significant advances, water management strategies might be reconsidered. But for now, experts clearly state that a mega project creating an inland sea is off the table. That said, politics can always be unpredictable. From time to time, emerging water crises or shifts in political will could bring this grand dream back to life. Although the latest analyses have weakened claims that the Bradfield scheme could save the climate from drying out, there's still a lingering question in the human mind. Maybe one day, with new technologies, could it be solved again? For now, the answer seems to be not very likely. But John Bradfield's bold vision will never be completely forgotten. Thank you for watching, and see you in the next video.